Okay, just to give you guys an idea of where I am, I'm at the Boys and Girls Club. It's getting cold outside, and it's about 20 minutes until Ariel's game starts. So while they're warming up, I thought I'd come out here and make this video for you. These problems, if you got them correct, at least listen to the explanation to make sure that you got it, not because you were guessing, but because you know what you're doing. And the ones that you missed, especially, are the ones that you need to pay attention to. The Johnson family subscribes to a cable television service at a monthly cost of $43.75, including taxes. If they use the service at this rate for 2 years, what will be the total cost for the cable service? So they tell you how much it is every month. How many months is 2 years? That's 12 months. So you're going to have to take $43.75 times, not 12 plus 12, which is 24. So, oh my goodness, I almost wrote 12. But it's times 24 because it's every month for 24 months. 5 times 4 is 20. 4 times 7 is 28 plus 2 is 30. 4 times 3 is 12 plus 3 is 15. 4 times 4 is 16 plus 1 is 17. And then we have 2 decimal places in our problem, so 2 in our answer. Oh, no. I'm not done yet because we still have to take 2 times everything. Okay, so let me get rid of that little decimal point right there. All right, now we have to take 2 times 5. Well, remember, when you start a new row, put 1 0 for a placeholder there. And then 2 times 5, the answer is going to start lining up under the 2. 2 times 5 is 10. Carry your 1. 2 times 7 is 14. Plus 1 is 15. Carry my 1. 2 times 3 is 6. Plus 1 is 7. And 2 times 4 is 8. Now, add those together. 14, 15, 10. And now we put our 2 decimal places in there. And our answer is D. I'm deleting these super quick, so if you missed out on something, make sure that you rewind it if you need to. Why isn't it trying to change colors here? Okay, number 2. After a back-to-school party, 7 friends had 3.5 watermelons left over. They decided to take an equal share home. How much should each person take home? Okay, you have to know what number is going to go first, and that's whatever it is that's being split up. In this case, it's the watermelon that they're dividing up, not the friends. So it's 3.5 divided up into 7 groups because there's 7 friends. And remember, before you can divide, you have to go ahead and change that to a fraction. It's going to be an improper fraction. You guys are really, really good at this. 2 times 3 is 6, plus 1 is 7. So that's 7 halves divided by, okay, how do you change 7 to a fraction? You just put a 1 in the denominator. I'm cold, so I'm like, blah, 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 blah. Okay, now remember that this is when we do the keep, flip, flip. Every time I write that, I think KFC. All right, keep, flip, flip. So it's 7 halves that we're keeping. We're flipping that and flipping that. Okay, now the nice thing is that we can cancel the 7s out. 7 goes into 7 once, and 7 goes into 7 once. And let's multiply straight across. 1 times 1 is 1, and 2 times 1 is 2. So everybody is going to take home half of a watermelon. That sounds good, except it's cold outside, not hot. Number 3 is saying that if you take 132 times any number in the whole wide world, we don't know what it is, we're just going to put a number there, it's got to equal a number that's less than 132. So when you take it times 132, it needs to come out less than 132. Well, let's explore this for just a minute. And we've talked about this in class. 132 times 1 is equal to 132. So whatever you put here has to be less than 1 whole. Okay? So that's what it needs to be for this little inequality to be true. It needs to be 132 times any number less than 1. Well, remember, this is saying which one of these cannot be used to keep it true. So let's look for the number that's greater than 1. Okay, 5, 6 is less than 1 whole. 3 out of 4, 3/4 is less than 1 whole. 8/11 is less than 1 whole. But 5/4, it's improper, and that means that it's greater than 1 whole. Number 4, what's the value of 112 divided by 5/4? So remember, keep, flip, flip. 112, and we're going to have to put a 1 in the denominator because we have this fraction over here, 5/4. So 112. Okay, flip the division to multiplication, and then our fraction is improper, but when we flip it, it's a proper fraction. So keep, flip, flip, we did that, and now we're going to multiply just straight across. 112 times 4, I don't know my 4s all the way up to 112. 4 times 2 is 8, 4 times 1 is 4, 4 times 1 is 4, so that equals 448. And then 1 times 5 is 5. Look at this. That can't be our answer. It's not over there. But if you take 448, and I'm just now remembering that this is the one that the answer wasn't there, and I told you guys to write it in. 5 doesn't go into 4, but it goes into 44 8 times, and we have 4 left over. Bring down the 8, that's 48. 5 goes into 48 9 times, which is 45, and we have 3 left over. And this is where we do the backwards check mark. 89 3/5. 89 3/5. So that should be your answer there. Martha bought 27.5 feet of ribbon to decorate packages. She's not going to use all of that on one package. She estimates it will take 2.5 feet per package. How many packages will she be able to decorate with her ribbon? So she has all this ribbon. She has 27.5 feet of it, and she's going to put it into groups of 2.5. Okay, before she works with these fractions, these mixed numbers, she has to change it to an improper fraction. So 2 times 27 is 54, plus 1 is 55, denominator stays the same, divided by, and then 2 times 2 is 4, plus 1 is 5 halves. All right, let's do keep, flip, flip. 55 halves times 2/5. The beautiful thing about this is that 2 goes into 2 once, 2 goes into 2 once. We can cross cancel. 55 and 5. 5 goes into 5 once, goes into 55 11 times. And now we're ready to multiply. 11 times 1 is 11, and 1 times 1 is 1. And of course, that simplifies to just 11. So you should have put 11 right in front of that decimal. Which statement is true? If a quantity is multiplied by a fraction, so any number, let's start with 5, is multiplied by a fraction whose value is between 0 and 1, then the product will be greater than the original quantity. So if 5 is the original and we take it times a fraction that's greater than 0 but less than 1, let's say 1/2. Well, guys, remember, any number times 1 is equal to itself. So if it's times a number that's less than 1, then your answer is going to be less than itself. So this cannot be true. G, if a quantity is multiplied by any fraction, then the product will be less than the original quantity. So if we start with 5 and we take it times, let's say, that's my husband. Should I answer it? So in class, over and over again, I get to hear my phone ring. Okay, so multiply by any fraction. So let's say 5 times 9 halves. That's a fraction, right? But you know what? That fraction is greater than 1 whole. It's an improper fraction. So a number times any fraction is going to equal a number less than the original. That's not true, because this right here is a fraction and it's greater than 1 whole, which means my answer is going to be greater than 5 times 1, which is 5. All right, if a quantity is multiplied by a fraction whose value is between 2 and 3, then the product will be greater than the original quantity. Okay, so let's start with 5 again. And a fraction that's greater than 2 and less than 3. So that would be like 5 halves, which is equal to 2.5. Okay? It's going to be greater than the original quantity. So yeah, 5, that's times 5 halves. That's, you guys, that's greater than 1 whole, which means our answer is going to be greater than 5. So it's this one right here. A group of 9 friends decided to equally share the $58.77 cost of refreshments for their party. They also agreed to equally share the $32.33 cost of the decorations. How much would each person pay for the party? So let's find out how much all of that costs together by adding it together, and that's $91.10. And how many people are there? There's 9 people there. So I'm going to divide 9 into $91.10. 9 goes into 9 once, which is exactly 9. I have nothing left over. Bring down the 1. 9 into 1. It doesn't go. 0 times 9 is 0. I have 1 left over. Bring down the 1. That's 11. Okay. This decimal that's right here should have a decimal on top of it in the answer. 9 into 11, just once, which is 9. And I have 2 left over. Bring down the 0. That gives me 20 down here. 9 into 20, it goes twice, which is 18. And I have 2 left over. If I want to keep going, I can. All right, but if it's money, we just need to look at the first 2. And that's $10.12. And of course, you don't see that answer, so the correct answer is not here. Number 8, a pitcher holds 6 4/10 liters of water. How many 4/10 liter glasses of water can be poured from the pitcher? So you have all these 6 4/10 liters, and you're going to break it up into groups that are 4/10 of a liter big. And so that's the problem. So the first number goes into the box. 6 4/10 divided by 4/10. And remember that you kick out the decimal. You move it to the end of the number. Just kick it out. It took you around 1 number, so you're going to go around 1 number over here. And now you have 4 into 64. That's what that looks like. So it's now 4 divided into 64. 4 into 6, it goes 1 time. You have 2 left over. Bring down the 4. 4 goes into 24 6 times. And that's your answer. Lori marked and labeled these numbers on a number line. Which did she mark and label furthest to the left? So which one has the most units away from 0 is what it's asking. So to the left. First of all, 2/3 is on the right side, but I'm not sure. This is probably a mistake, or maybe this should have had negative in front of it. But either way, this right here is more than 1 whole unit away from 0. Okay? This is not, and this one right here is not more than 1 whole unit away from 0. So the ones that we need to compare, there's the cat, is -1.5 and -5/4. So when you're comparing fractions and decimals, you need them either to both be as a decimal or both be as a fraction. So I'm going to change this right here to a decimal. So it's TBO, top in, bottom out, 5 divided by 4. and that gives me 1 left over. Add a 0 and bring it down. Bring down that 0. 5 into 20 is that. So we have negative 1 and 2500ths and negative 1.5. Both those numbers right there. Which one is the furthest away from 0? It's going to be this one right here. This is like $1.50, and this is $1.25. $1.50 is more, so it's more units away from 0. Oh my gosh, that cat. Which statement is true? First of all, you look at your whole numbers. We have a 2 and a 2. 2, 2. 2, 1, and 2, 2. So let's look at this one first, because that's the obvious. You can just check the whole numbers. 2 and anything is less than 1 and anything. Well, first of all, 2 is greater than 1 whole. So we know that H is wrong simply because 2 is greater than 1, not less than 1. So I'm going to mark it out. Now, when we're comparing fractions, remember I taught you all you have to do is just cross multiply. 4 times 1 is 4. 3 times 1 is 3. Is 3 greater than 4? No. 4 times 1 is, I'm going to switch to green. Okay, changing colors. 4 times 1 is 4. 4 times 3 is 12. Is 12 less than 4? No. So let's eliminate that. I don't think I like this green very much. And then down here at the bottom, 2 times 1 is 2. 4 times 1 is 4. 4 is greater than 2. So that one seems to be the one that's correct. Yay! Which of the following fractions would not be found between 1/4 and 11/32 on a number line? So we have to figure out which one is greater than 1/4 but less than 11/32. So we're going to look at 9/32. Okay, I'm going to put that in the middle. And let's start comparing. 4 times 9 is 36. 32 times 1 is 32. And 32 is less than 36. So let's see if 36 is less than this cross product over here. 32 times 11 is 352. And then 32 times 9. Okay, I don't even have to multiply that to know, because 32 times 11 is 352. 32 times 9 has to be less than that. But just to prove it, 27, 28, 288. So 32 was less than 36. 288 is less than 352. So it's that one right there. Which statement is true? Okay, remember that these marks right here is absolute value, and absolute value is the distance from 0. So the absolute value of positive 12 is 12, because it's 12 units away from 0. Is that less than the absolute value of negative 12? Well, what's the absolute value of negative 12? Since negative 12 is 12 units away from 0, the absolute value of negative 12 is 12. Is this statement true? 12 is less than 12? No. The opposite of 12 is less than 12. What is the opposite of 12? It's negative 12. Is that less than 12? Well, yes, it is. Your answer is G. Look at H, the absolute value of 12, which is 12. Is that less than negative 12? No, it's greater than negative 12. Any positive number is going to be greater than any negative number. And then let's look at J. The absolute value of negative 12 is 12. The absolute value of 12 is 12. So is 12 less than 12? No. So G is your answer. Isabel, you want to say hi?
Hi.
Delight. Okay, number 13, which list shows the integers from greatest to least? So first of all, I'm going to mark out this because that's starting with negatives and going to positives. Okay, greatest to least. So that's positive 4, and then we jump to negative 2. And as we are moving down this list, we're getting actually closer to 0. Okay, so it can't be that. The closer you get to 0, the bigger the numbers are on the negative side. Look at B. Positive 4, and then negative 1 is the closest to 0, and then you're getting further away from 0. Negative 1, negative 2, negative 3. That means your numbers are getting smaller. Here you're at 4, and then negative 3, negative 2, negative 1. You're getting closer to 0. So it's like you started here, and then you jump to here, and then to here, and then to here. If you're going greatest to least, you're going to be moving this direction the whole time, not jumping around. Okay, so negative 1/2 is going to be halfway between 0 and negative 1. This one is not halfway between 0 and negative 1. Halfway would be right here. So F is not right. Let's look at G. The negative 1/2 is halfway between 0 and 1. That's good. But look here, negative 1.5 should be halfway between negative 1 and negative 2. So that's not true. For H, look how close that negative 1/2 is to 0. Again, negative 1/2 should be halfway between 0 and 1. Negative 1, right there. That's not true. And then for J, negative 1/2, look, it's halfway between 0 and 1/2. Negative 1/2 is halfway between negative 1 and negative 2. And then negative 2 3/4 is the 1/2 mark away from negative 2. So it's that one. Okay, this next problem. Johnny worked 14.5 hours last week at the local newspaper office. He's paid $6.50 per hour. How much money did he earn last week? This is like if you added for every hour $6.50. For every single hour, $6.50, $6.50. And you learned in elementary school that the fastest way to do that is just to multiply. Well, this is the same idea, except now you have decimals. 650 times 14.5. And notice my decimals are not lined up, but my numbers are. Okay, I'm going to go ahead and multiply this. 5 times 0 is 0. 5 times 5 is 25. Carry the 2. 5 times 6 is 30, plus 2, that's 32. And then I'm going to start a new row. So there's my placeholder. And then 4 times 0 is 0. 4 times 5 is 20. Carry my 2. 4 times 6 is 24, plus 2 is 26. Now I'm going to start a new row. I still have to multiply 1 times everything, so I'm going to have 2 placeholders this time. 1 times 0 is 0, 1 times 5 is 5, 1 times 6 is 6. And now what happens? We add all these numbers together. And we get, okay, let's count our decimal places now. We have 2 decimal numbers here. We have 1 here. All together, that's 3. So 1, 2, 3, $94.25. Go take your retest now.